afternoon seeing you. My name's Emma Byers and this is my co-host, Kelsey Lewis. Today we'll be talking to you about ATP Synthase. Kelsey, what kind of news do you have to bring about this wonderful little enzyme?
Well, Emma, this enzyme is apparently incredibly important to our daily lives. Apparently, if we don't have ATP synthase, basically it's an enzyme that creates ATP. So, and ATP is kind of a necessity to maintain homeostasis and to have our daily routines. So, we're going to go to our reporter, John, and he'll give us a lot more information on this fascinating enzyme.
Oh, hello there. I'm at the gym. I don't know why you're here, but I'm going to do some push-ups, so you can join me on the floor if you want.
Now, I'm not doing this just to show off or anything. I'm actually doing this for science, okay? Ugh. You see what happened there?
My arms moved, my shoulders moved, my back and stomach muscles moved, my heart pumped blood to all those different places. It's pretty neat, huh?
Well, it turns out that how we make and use energy is a lot like sports or other kinds of exercising. It can be hard work and a little bit complicated, but if you do it right, it comes with some tremendous payoffs. But unlike hitting a ball with a stick, it's so marvelously complicated and awesome that we're still unraveling the mysteries of how it all works. And it all starts with a marvelous molecule that is one of your best friends, ATP.
Our push-ups. So that's all well and good, but here's the thing. We can't just use that energy to run a marathon or something. First, our bodies have to turn that energy into a really specific form of stored energy called ATP, or adenosine triphosphate. You've heard me talk about this before. People often refer to ATP as the currency of biological energy. Think of it as an American dollar. It's what you need to do business in the US. You can't just walk into a Best Buy with a handful of Chinese yen or Indian rupees and expect to be able to buy anything with them, even though they're technically our money. Same goes with energy. In order to be able to use it, our cells need energy to be transferred into adenosine triphosphate to be able to grow, move, create electrical impulses in our nerves and brains, everything. A while back, for instance, we talked about how cells use ATP to transport some kinds of materials in and out of its membranes. To jog your memory about that, you can watch that episode right here. Now, before we see how ATP is actually put together, let's look at how cells can cash in on the energy that's stashed in there. Well, adenosine triphosphate is made up of a nitrogenous base called adenine with a sugar called ribose and 3 phosphate groups attached to it. Now, one thing you need to know about these 3 phosphate groups is that they are super uncomfortable sitting together in a row like that, like 3 kids on a bus who hate each other all sharing the same seat. So because the phosphate groups are such terrible company for each other, ATP is able to do this nifty trick where it shoots one of the phosphate groups off the end of the seat, creating ADP, or adenosine diphosphate, because now there are just 2 kids sitting on the bus seat. In this reaction, when the 3rd jerk kid is kicked off the seat, energy is released. And since there are a lot of water molecules just floating around nearby, an OH pairing, that's called a hydroxide, from one of the H2Os comes over and takes the place of that 3rd phosphate group, and everybody is much happier.
Thanks, John. That was some very intriguing information on that fascinating enzyme. Now we're going to go to my lovely co-host, Emma, who will give you some more information on this enzyme.
Thanks, Kelsey. Here we have an ATP synthase molecule located in the mitochondrial membrane. There's a higher concentration of protons on the outer side of the membrane, and this allows for a concentration gradient, which will make it easier for the hydrogen ions to get into that ATP synthase complex. So, as the hydrogen ions come into the ATP synthase complex, one will bind to the inner rotor while another one comes into the matrix space. Once 3 protons have bound to this inner ATP synthase rotor, it will finally make enough energy to synthesize an ATP molecule from one ADP molecule and one inorganic phosphate molecule. Back to you, Kelsey.
Well, thank you, Emma. I don't know about you guys, but I'm pretty glad we have Emma over here to understand that mechanism. Anyway, now we're going to go over to our sportscaster, Dan, who will tell us more about this extravagant enzyme.
If you didn't have ATP synthase, and if you couldn't make ATP, then these are some examples of what will happen to you. Your legs could just give out on you. If you don't have enough energy in your muscles to burn, this is what also could happen to you. And boom goes the dynamite. Now back to you all in the studio.
Thanks, Dan.
Really enjoying that prototype. Thanks for tuning in today on WKDE. Have a very nice weekend, and we'll see you next time. I'm Kelsey, and this is Emma. Stay classy, San Diego.